Right. So Aliyah, give this a read.
The length of the side of a square is increasing at a rate of 4 centimeters per second. Find the rate of increase of the area when the length of the side is 5 centimeters.
Okay, so first things first. With these questions, you need to understand what's going on. So they're saying that the length of a square is increasing at a rate of 4 centimeters per second. So Aliyah, according to that first piece of information there, what is changing with respect to what?
The length of a side is increasing
With
at
respect to?
with respect to 4 centimeters per second.
Okay, here we're asking you, what is changing? What we know changing there?
The length
And that is changing with respect to 4 centimeters length
second
per second.
time
Right. So as time passes, what happens to the length of the square?
is increasing.
So the length is dependent on the
Time.
correct. So if we were to come up with a differential expression for that, you would say d what over d what.
Um,
So dy dx means the change in y over the change in x, or the change in y with respect to the change in x. So what would
so
this be?
the change in length over
With respect to?
with respect to with respect to time.
Correct. So I would write dl dt. So the length is changing at a rate of 4 centimeters per second with respect to time. Some of you understand that.
Yeah.
Cool. So in these questions, typically you'll get a piece of information that gives you a piece of information wholesale like this. It tells you that the LDT is 4 centimeters per second. You put that aside. Next part of the question. This is usually the question part. So I'll read the question part. Find the
Find the rate of increase of the area.
stop there. They want us to find the rate of increase of area. So what is changing there? If we say in rate of increase of area, what is changing there?
The area.
The area. And everything changes with respect to anytime you see rate, what we typically talking about. Think about it. If I ask you, what is the rate at which you're losing here? What what is it? What is it being like? If I ask you that question, right? What you tell me? Granted, you're not losing here. I'm just saying, if I ask you that, what's the rate at which you're losing here? What you tell me? Make up a situation.
Me.
Yeah.
Like, okay, wait, what do you mean? Like
What is the rate at which you're losing here?
losing hair?
Okay, let me get a better one. What is the rate at which you're driving?
Um, that's kilometer per hour.
Right. So anytime you see rate, it's always referencing time. Keep that in mind. Anytime you see rate, we're referencing time. Something is changing with respect to time. So
Mm-hmm.
that's dA over dt. So they want us to find dA dt. That's what they want us to find, dA dt.
Okay.
And they said, what did they say next? They gave us another piece of information. They said,
When the length of the side is 5 centimeters.
right, when the length is 5 centimeters. Okay, so we have some pieces of information here. And we need to find dA dt. So Aliyah, let me show you how we're gonna do this. Right? So Aliyah, remind me, what do we want to find for?
The rate of increase of the area. So dA over dt.
Right, dA over dt. Right, dA over dt. And how will we find this? Recall from the chain rule. If you recall the chain rule, when we're doing a chain rule question, it's typically two different rates of changes multiplied. So we're going to multiply two different rates of change, and the main goal is to get dA dt. So Aliyah, let me show you what I'm talking about. If we were doing a regular chain rule question and you had to find the dy dx, you would say dy du by du dx, and the du's would cancel off.
Mm-hmm.
I want you to apply that same concept over here. If you wanted to get dA dt, what would you do? What would you do to get that? What would you have? What do you need to have over here? What do you need to have over there?
Um, that would be
So you see,
dy
obviously,
dx. No, it could be
what has to go here?
dA.
Yes, dA. Right? What has to go over here? Well, we will figure it out later. We'll figure it out later, right? What has to go here?
dt.
Dt. So let me look at all the information we have so far and try to figure out what we're gonna put here and here. But what we put over there, it has to be the same, right? So are you seeing any other variable in the question? So we're seeing time, we're seeing area. What else we seeing?
The
Length. Yeah, so we can put DL and DL. And then if we do that, it could cancel off and it give us DADT. Aliyah,
yeah.
you confused?
No.
No? You're someone confused.
Sorry. No.
So again, we're trying to get DADT. We need to figure out what we're going to put over here and over here. Let's look at the question.
Mm-hmm.
In the question, well, they gave us DLDT. That has another variable, L. So I could put that over here. I could put that L over here.
Mm-hmm.
And if I put in L over here, well, I could put L over here as well.
Mm-hmm.
Because that's the only way it would cancel off to give us DADT.
Yeah.
Now, my other question is, if we know DLDT, we would need to figure out DADL. So we need to figure out the change in area with respect to the change in length. Now, with these questions, you typically have to remember the formula for area. So what kind of shape do we have in this question?
A square.
We have a square over here, right? And if it's a square, is there a formula for area that you know?
Yeah. Side by side.
Side by side. Well, in this case, we're going to use length by length. And we need to figure out the ADL. How would we figure out the ADL?
Um. Hmm.
It's very
dt.
simple, I promise. So A is equal to L squared. And I need to figure out the ADL. Okay, imagine if you had y is equal to x squared. What would dy dx be?
Oh. That could be 2x.
Yeah, so what is going to be?
That could be 2L.
Yeah, that'll be 2L. And they said when the length is, what did they say? When the length is?
5 centimeters.
Correct. And I want to make something apparent. Aliyah, when we're doing rates of change, the units come in handy a good bit of the times. So watch this, right, Aliyah? If you have area over length, area will be measured in centimeters squared and length will be measured in centimeters. And
Yeah.
so if I have a centimeter here and one of these centimeters will cancel off with one of it on top,
Yeah.
and it would and the remaining units will be centimeters. If you're confused, I'm gonna show you that one more time. So centimeter squared and centimeter squared is centimeter by centimeter.
Mm-hmm.
So you would remain with centimeter. Okay?
Yeah.
And over here we're seeing 2 by 5 centimeters. What is 2 by 5 centimeters?
10.
10 centimeters, right? And we got 10 centimeters. And according to DADL, which is area over length, what units am I supposed to get?
Centimeters?
Right, so do I get centimeters?
Yeah.
So we're good. So DADL, that's 10 centimeters, and you multiply that by DLDT. DLDT, remind me what I was?
The LDT
What was
was
DLDT? That was given to us.
no.
It
Oh, that
was,
was 4.
right? 4 centimeters per second. So what is 4 by 10?
40
Right, so 40, the cm and the cm going to multiply, so that'll be 40 centimeters squared per
per
second.
second.
And let me check if that makes sense. If you have area over time, area is centimeters squared over time, which is second. Are we seeing we get the same units?
Yeah.
Yeah, so this is the correct answer. So with these questions, I'm going to run through the basic steps. You're going to pull apart the pieces of information. Pull apart the piece of information that's given to you wholesale, find out what the question is, and find out what any other pieces of information is. Depending on the type of shape, we're talking about a square, a circle, a rectangle, a triangle. You need to recall the formula for area. If it's a cuboid, cube, something like that, you need to remember the formula for volume, right? Once you have those things in mind, you're gonna take what you need to find. So Aliyah, in this question, we needed to find the ADT, right? You're gonna you're gonna pass side where you need to find, and you're gonna use the chain rule to figure out what else you need. So for me to get DADT, I would have to say DADL by DLDT. DLDT was given to me, so I need to figure out DADL, which is just a change in area with respect to the change in length. So we recall what the formula for area is. I differentiate, and over here, since it told me the length is 5, I plug it in. So now I know what DADL is. I plug it in. I plug in what DLDT is, multiply, and I get my answer. Aliyah, you understand?
Yeah.
Okay. Aliyah, we should I copy down this over here, or like the full working?
Um, full again.
Okay. Give me a second again. I'll call guys. So copy this song in the meantime.
You could just scroll back up to the question, please.
Yeah, so copy that down.
You could scroll down to the root there now.
All right. Okay, sorry about that, guys. I'm in a little bit of a situation here. Did you all get the chance to copy this down?
Yeah.
So, Ali, I have that down, right?
Mm-hmm.
So I want you to identify the general steps. If you have a question like this, they usually come the same way. I want you to identify the steps. So try to identify the steps to me. How did I do this question?
Um,
What was the first thing I identified?
we identify the length that increases at a rate of
Okay, and what would that fall under? Information like wholesale information?
yeah.
Yeah, that's a fact. That's a
Mm,
fact. So we pull out the fact. They will give us a fact, and that's a whole piece of information by itself. The next thing, they will ask you a question. You need to pull aside that question. Next thing, they will give you an additional piece of information. You put that aside. So fact, question, other piece of information, right?
mm-hmm.
And you will need to remember the formula. In this case, we're dealing with area of a square, right? If we have area of a square, then that is L squared, right? You with me?
Yeah.
Okay, let me give you a question now. All right, I want you to try question C. Try question C. This over here. All right, so I want everybody to try this question for me. Amy, if you didn't do this question yet, try it.
I did the question already.
Oh, you did the question already?
Yeah, it was the second question we did too.
All right.
Yeah.
So here what? In the meantime, while we wait, let's see if we could do one of the mixed questions, right?
Okay.
Right. So we're gonna go on the chat. Question, did I send you a picture of the mixed questions or did you copy it down? Not seeing anything over
Always and the PDF with all.
on the advanced chat.
No, privately.
I'm not seeing it.
I could resend it.
Yeah, resend it. Right. So Amy, just confirm any session for tomorrow, right? We're gonna have that session tomorrow. So,
Yeah.
right? Nice. So cylinder surface area. A cylindrical can is being filled with water at a rate of 7 centimeter cube per second. So is that a fact?
Yeah,
So is that a fact?
yeah.
That's a fact. So how will we represent the rate of change there? So they said a cylindrical can being filled with water at a rate of 7 cm cube. If we're talking about cm cube, what is that?
Volume, so it's dV over dt.
Right, dvdt is equal to 7 centimeter cube per second.
Mm-hmm.
If the radius of the can is 3 centimeters, okay, they're giving us a piece of information, probably write that down. How fast is the surface area of the water increasing when the height of the water is 5 centimeter? So they want us to figure out how fast is the surface area of the water increasing.
Mm-hmm.
So again, they want us to figure out how fast the surface area increasing.
Are they
Anytime we're talking about rate or how fast something increasing, we're dealing with time. So that'll be d what over d what.
dA over dt?
Correct, dA over dt. So dA over dt is what we're trying to find.
I did piece of the working, but when I was going to differentiate the um wait, I would send you what I have.
So now we have.
It's not much though, but I come with I reached the same problem when I was doing the other question. So
So now we
okay.
have an answer.
This is the last stop.
So check we have. Right.
When I was going to differentiate, you know how you were saying um that wait, when you have the area and you're supposed to have like differentiate something out of it. When I was trying to do dA over dV, I wasn't, if that making sense.
Hmm.
Yeah, that's why I kind of went into problem.
I see.
Yeah.
Wait, so I'm getting a call. Give me a second. Yeah, Amy, sorry about that. Like I said, dealing with that situation here. Real frustrating. Ooh, let me let me check back. It was doing. Aliyah, you make any progress by the way?
E I think so.
You think so?
Hmm. I get
All right.
the I get the formula.
Listen.
I get the formula. Well, what you have, I get what I find out what I have to find.
Okay. Now you need to figure out what you had to multiply by what to get the answer.
Yeah.
Okay. Um, Anybody else trying this question?
The volume, right? Leave it just so or work it out. No, I gotta leave it just so.
They want it in terms of pi.
Okay.
All right. So Amy, I'm gonna get back to you, right? Okay. Nicholas, you sent my answer. Let me check it out. Nicholas, what do you mean dVdt is equal to 4 over 3 pi r cubed? How that make sense? Now that don't make sense. I'm not sure how you get that. You're saying dVdt is equal to 4 over 3 pi r cubed. I think you mean to say dVdr. And Nicholas? Yeah, so that's supposed to be dVdr. dVdr is equal to 4 pi r squared. Okay. Yeah, Nicholas, you're working kind of confusing. Hmm. dRdt is equal to, yeah, I'm not really sure what you did there. Um, Aliyah, you getting through?
I don't think so.
You don't think so?
I mean, I know how to do. It's just like
Okay, tell me, what was the key piece of information you had to pull out?
um the volume
It's a,
and the rate.
right? Yeah. So Aliyah, let me follow the same procedure as last time. What is the fact here? What is the fact in this question?
The volume and the rate,
The volume and the rate.
and they give us the radius.
Okay. So tell me the first piece of information that we know is a fact.
Um, these equal to 40 pi r cubed.
Right? And what is the other key piece of information?
Rate is equal to
Wait, don't
200.
just say rate. You have to tell me the differential. So a spherical balloon of volume is being filled with air at a rate of 200 centimeter cube per second. What is that? What does 200 centimeter cube per second mean? That's what over what? What is changing with respect to what?
dV over dr
The R. Where you get R from?
or dt.
Yeah, so look at it, right? The
Yes, yes, I,
volume, yes,
okay.
right? Calculate in terms of pi the rate at which the radius is increasing when the radius of the balloon is 10 centimeters. So, Aliyah, what do they want us to find?
Um, the rate of change.
The rate at which the radius is increasing.
Yeah, and
Wait,
the
give
interval.
me a second.
Okay.
All right. Yeah, so Aliyah, let me continue. So they want us to figure out the rate at which the radius is increasing. So what do they want us to find then? What over what? What do they want us to find?
Um, rate of
Say that
change.
again? I'm not hearing you.
No, I'm talking to myself.
Okay.
Um, dV over dr.
Say that again?
dV over dr.
You gotta explain yourself to me, right? Where you get V from? Tell me where you get V from. Where you get V
Um,
from? I want you to read this more.
it could be dr.
Right? We dr over. Anytime you see rate, the rate at which something is increasing, what do we
Times
typically measure things with respect to?
dt.
Yeah. We typically measure the rate with respect to time. Like
Yeah.
I losing my hair every 5 hours. You know,
Mm. Yeah,
I can reach there in 2 hours. Something so.
yeah. Okay.
That's what we're trying to find. We're trying to find for DRDT. That's what we're really trying to find for. And they also told us when the radius is 10 centimeters. So that's the pieces of information they gave us. Right? So we need to figure out DRDT. So I'm gonna write that over here. I'm gonna say DRDT And the RDT will be equal to what? If you had to say earlier, what would that be equal to?
Um, the RDT could be equal to
What is supposed to have over here and over here? What is it supposed to have over here and over here?
the V.
Wait, okay. You gotta explain yourself to me. Where you get V from?
DT then?
Think logically. Where DT is in the denominator. Why would you want to put DT on top?
Okay, so DR.
The R would need to be here. And what would need to be here?
DR, let's account for it.
But then how you get the R? You
So
need to
then
get the R.
it would be
Say that again.
um it could
You
be
need to
V DT.
right, and whatever you put here would be the same thing. So you would cancel off to get the RDT.
Oh,
Yeah. So what is the other variable you seen in this question? Look at this question. What is the other variable you see in it? So we have R, we have T. What else we have?
V.
We have V. So I'm gonna put
So
DV. I'm gonna put DV over here, and I'm gonna put DV over here. Think you could figure it out? Figure it out now?
yeah.
All right. So we need to figure. It actually might be. It have a little trick in this question, right? So we have DVDT. What's DVDT?
200 cm cube per second.
Right, 200 cm cube per second. DRDV. Where do you think we're gonna get DRDV from? We had to get that from some equation. What's the only other equation you seen in this question?
V is equal to pi r cube.
Forward.
Footed, sorry.
Right. But if I have, I'm asking a question, right? If I have V is equal to 4 over 3 pi r cubed.
Mm-hmm.
If I have this and I differentiate this, what would I be finding for? If I differentiate this,
You'll be fine for V.
I would be dv over, and what is the only variable in this question? I mean, in this
Pi.
equation.
Pi.
So you'd be finding for dvdr. Well, you said pi was a variable.
Oh,
You just now
no.
said pi was a variable.
No.
Whoa, whoa. Not so fast there, buddy. Pi is not a variable. Pi, what is pi? What we know pi is?
22/7.
3.1. Yeah. Right?
Yeah.
So if I differentiate the volume with respect to the radius, what would that be equal to?
Um, that'll be 4 pi r squared.
Yeah, correct. No, that look at this carefully, right? That's DVDR. That's DVDR. What do we need
Mm-hmm.
here?
dr dv.
So we think we had to do this. It's simpler than you think.
Um,
If I had 1 over 5, what would I do with 1 over 5 to make it 5 over 1?
you invert the fraction.
Right. And if I flip this side, I also have to flip this side, right? So if I flip DVDR, that'll be DRDV. And if I flip 4 pi r squared, what that'll be?
1/4 pi r squared.
Right. And what is radius? What is the radius?
The radius is 10.
Right. So we need to plug in that over here. Right. So we're gonna end up with what? 1 over
Um,
So where's 10 squared?
100,
What is 100 by 4?
400.
400 pi. That's it.
Okay.
Right, so now that we know what drdv is, we're going to plug that into over here. So that'll be 1 over 400 pi, right? Multiplied by dvdt. What is dvdt?
PVDC is 200 cm cube per second.
Oh, before we do anything, let me just put the units for this. If I have radius is measured in centimeter, and volume is measured in centimeter cube. What would this work out to be? What is cm over cm cube?
Um, Centimeters.
So this centimeter on top would cancel off with one of them over here. So what
Centimeters
is
squared.
what is 1 over cm squared? Wait, I don't know what happened. Yeah, what is 1 over cm squared as a odd math student? You had to know this one. If I take cm squared and bring it up to the top,
Oh, it will be centimeter
to the
to the
power
minus to the
minus
power
2.
minus 2, yeah.
Right, so we have cm minus 2 here, multiplied by dvdt. dvdt is 200 centimeter cube per second. Right. So let me work this out. So Aliyah, the 200, 200 into 200 is 1, 200 into 400 is 2. So you would end up with 1 over 2 pi. Let me look at the units now. Aliyah, what is cm minus 2 by centimeter cube?
What? CM minus 2?
By cm cube.
That could be,
Same base. Say if you have the same base and you multiply and you add the powers,
yeah, add the power, so it'll be centimeters.
right? Centimeter, right? And s minus 1. That's it. Yeah. So if you understand that.
Yeah.
So explain the question to me. So Nicholas, even though you got the answer, your work needs to look like this. It needs to be properly structured. Otherwise, I don't think you're gonna get a max. Yeah, so Aliyah, try to explain this to me, please.
Um, okay, so in the question, they gave you information to
Okay.
work with.
What was the information?
They gave you the volume,
Mm-hmm.
they gave you the rate at which the radius is increasing. No, they give you
No.
the radius of the balloon, and they
Mhm.
give you
No.
um
You
they give
gave us
you
the radius, and what is 200 centimeter cube per second mean?
the rate at which the
CM,
balloon is being filled,
right? What does cm cube represent?
the volume.
Right. So tell me it in terms of volume and time and thing.
Um, the,
The rate at which the what is being
the rate at which the volume is being changed.
right with respect to
Time.
yes. So they gave you dvdt. Continue.
Yeah. So they they wanted you to find the rate at which the radius is increasing in terms of pi. So that would be dr over dt,
Second.
and
Yeah, yeah. The RDT. So they
yeah,
want to figure out the rate at which the radius is increasing, so that'll be radius with respect to time. That's
yeah,
the RDT, right? Um, when the radius is 10 centimeters,
yeah.
right? I give me a second. I had to make a call. Like I tell you, in a situation right now. Uh,
Okay.
Aliyah, try to process the question in the meantime. If anybody didn't copy it down now. All right, guys. Yeah, sorry about that. Sorry about that. Aliyah, I get time to process what's going on here.
Yeah.
Yeah, sure.
Yeah.
Okay, so what's the main thing we just pull out? What are the main things we pull out from the question?
The volume.
Well, it could be a different question. It doesn't have to be volume.
Oh, we ask
What are the main things you want to pull out in these types of questions?
um where you find like what they give you, which is
Say that again.
like area or like volume.
Right?
I'm kind of
Yeah, you need to know that. What else you need to know? What else you need to pull out?
um what changing with respect to like time or like length.
Yeah, yeah. So in this question, they said they told you it's being filled at a rate of 200 centimeter cube per second. Centimeter
Yes.
cube is volume, S is time.
Yeah.
So dVdt.
Mm-hmm.
Next thing, they will ask you something. You need to pull out what they're asking you and write it in differential form. So that's dRdt. They told you what the radius is. Cool. Then you're gonna use the chain rule to figure out where you need to find.
Yeah.
So yeah, this part you need to understand. If I need to get dRdt, then dr has to be over here and dt has to be over here. Whatever
Okay.
whatever I have on top, it needs to be over here. Whatever I have on the bottom, it needs to be over here.
On the opposite side.
Right. And whatever you put over here has to be the same thing so that it cancels off.
Okay.
And then so like you see, they gave us the VDT, so we had that. So we just needed to find dRdV, right? We just needed to find dRdV. Understand?
Yeah.
So we have an equation with V and R in it. So we find dVdr and then we flip it, plug in R, get that. Once we got that, we multiplied it. So we plug it back in and we multiply that by dVdt and we got our answer. So let me give
Mm-hmm.
you our next question like this. I presume everybody would have had the chance to copy this down. So I'm going to move on to our next question. Right? So I want everybody to try this question here. All right, so I would like everybody to try that question. Water is poured. Try that question. Um, Aliyah, again, show this question.
Yeah, I just writing it down, please.
Okay, no problem. Amy, did you ever do this question here? That was on the screen.
No, I do not right now. But
Okay,
I
cool.
write my question, please.
All right, guys, any updates? Alia, any updates? Amy, Nicholas, Kiara, Kristen.
I try.
Okay. All right, did anybody get through with this question? Part C? Okay. Nicholas, I see you sent my answer. Nicholas, you're looking very peculiar. Nicholas, I know you can't talk, but type in the chat. I find you looking real sketch. Um, so you said V is equal to pi r squared H, right? Determine the rate of increase of volume of water. Let's see, 1 to 5 for dVdt, right? dH dt is equal to 2 centimeter cube per second. Hmm. It's just looking very rushed and incomplete. That's most likely the answer, but you're working very rushed. So, Aliyah, did you get through with questions with this question on the board?
I'm trying to work out. I'm trying to work it out.
Mm-hmm. So, Aliyah, what were the main pieces of information?
Um, the radius of the container,
So they gave you the radius. What else they give you?
the the height of the water, which increases at a rate of 2 centimeters per second.
And what is that? Tell me what is that? That's what over
Um,
what,
that's dH over dt,
right?
and they give you the volume, the formula for the volume
Right.
of a cylinder.
And what do you want me to find?
The rate of increase of the volume of the water.
Right. So that is what?
So there's, I don't know if there's dV over dt.
Yes.
Okay,
Anytime they talk about rate of increase, we're talking about respect to time.
right.
Always.
So it's always over dt.
Yes.
Okay.
If I ask you, what is the rate? At what rate? Let me see. Hmm. Like I say, if I ask you, at what rate are you losing your hair? Would you say you're losing your hair um with respect to money? You can see that?
No.
And you could tell me you're losing your hair like every 5 minutes or like every
Yeah.
2 hours or something or every other day. So if
Mm-hmm.
I ask you a rate and you could tell me with respect to time,
Yeah.
if I ask you at what rate the tank go and get filled up, and you could tell me, well, they'll get filled up by so on. So time is always
Mm-hmm.
time. You see, rate is time. So you need to find dVdt. So dVdt would be equal to what?
dV over dH multiplied
Right?
by dH over dt.
Perfect. Perfect. You know what you're doing. Right?
Yeah, I stuck on dV over dH.
You're stuck on dV over dH. Why are you stuck on
Yeah,
dV over dH? So
I don't know.
you're looking for an equation that has V and H in it. Which equation has V and H in it?
Um,
Look at the information you wrote down.
the
What
volume
equation?
of
The
the
volume.
cylinder.
So what do you think got to do with the volume to get dVdH?
Um,
If I have y is equal to something, what would I do to get dy dx?
to differentiate,
So what I'm gonna do with v is equal to pi r squared h to get v dvdh.
you differentiate the it could be 2 pi r h,
2 pi r h, yes, that's correct. That's correct. Hmm.
and it could be you're replacing the r with 15 because they give you the radius.
Yes,
So that could be 2 pi 15 h.
2 pi 15 h, yeah. So it's 2 by 15,
30.
right?
So 30 pi h.
Wait,
Or
um,
pi 30 h.
30 pi h.
30. Um,
Well, I'm gonna do the question quickly. So, um, I told the radius was 15. They said the water increases at that rate. So that is dH over dt. dH over dt is 2 cm per second. And they said the V volume is equal to pi r squared H, right? And they wanted to figure out the rate of increase of volume. So that dV dt. dV dt, that'll be equal to, I work in it separately, right? dV dt, that means dV on top, dt in the bottom. The other variable is H, put H there, put H there. To get dV dH, I would have to differentiate dV dH. That'll be equal to 2 pi RH, right? They gave us a radius as 15. So that'll be 15 by 2, 30, 30 pi h, right? Right.
would it be 60 by each centimeter per second?
Wait, something off.
Or,
Wait, Alia, let me look at this carefully, right?
mhm.
If we're saying dV dH, are we going to differentiate with respect to radius or height? Be careful.
Oh, it could be dr.
No, no, it's dV dH.
So how,
The reason why it has to be dH is because they gave you dH dt. They didn't give you dr dt.
yeah,
So let me ask you a question. So if we have So if we have V is equal to pi r squared h, right? And we
mm-hmm.
need to figure out dV dH. Are we going to differentiate the r squared or the h?
The h,
Right. So r
okay,
squared is a constant. We're going to treat r squared as if it's like a regular number. We're not going to do anything with that. So
okay,
if I had y is equal to, let me just say 2ax, and I find dy dx, what would dy dx be? Try to figure that out. So 2a, think of that whole thing as a number. So if you differentiate 2ax, what would you remain with? Okay, I'll be a simpler question. If I had 5x, if I differentiate 5x, what would that be?
5. So
5.
it'll just be 2, 8.
2a. So pi r squared. All of this is like a number because we differentiate with respect to h, not r. So if I differentiate this, that'll be
Pi r squared.
pi r squared. That's correct. If it was h squared, it'll be 2 pi r squared h. But it's not.
Yeah,
Yeah. Awesome. Awesome. So once you do that, you should get your answer.
okay.
It'll be fine. Nicholas, it just what you're doing is correct. You're just skipping a lot of working. A lot of working. Like if the question is with 5 marks, you're gonna get 3 marks. You're gonna get 3 marks. You gotta put it working. It's pretty working. So you had to say like dv dt is equal to dv over dh by dh dt, then plug it in. Yeah, yeah. You're like rushing there. You had to put it working. You have to put it working. Amy, let me see what you have. Yes, Amy, that's correct. That's correct there. Nice. So Amy, I didn't fully do the question yet, right? But let me give you a hint. In 7, you might have to find you might have to do the chain rule twice. Might. Might have to. Just saying. And Amy, I don't know if this might help you, right? But you want to see something really cool?
Yeah.
Amy, watch this, right? So check this out. So we know that the volume is pi r squared h, right? Wait. Um, yeah. You know that the volume is pi r squared h, right? And for question 7, it deals with a cylinder. Volume is equal to pi r squared h.
They
And
say they only give the surface area.
right, but we
Um,
know, as we know, V is equal to pi r squared h.
yeah.
So I want to show you something really cool. If I were to differentiate this with respect to radius, what would I end up with?
Pi 2 RH.
So 2 pi r h.
Yeah. Mm-hmm.
What just so happens to be what? What is that? What is 2 pi r h? What is 2?
Oh, the surface area, the
Yeah.
formula, the surface area.
So there's some hints I would throw at you, right? The cool thing about differentiation, if you differentiate volume, you'll get area. Yeah.
Okay.
And if you differentiate area, you should get perimeter, I think. That's how it is work. I'm gonna show you an example, right? Um, hmm, what's a good example I could give you? All right, so pi r squared. Check this out, right? Pi r squared. We know that is the what's that? What was pi r squared the formula for? Pi r squared is the formula for what?
Um, um,
Come on, come on. Using maths, boss, you had to know this. Does
um,
anybody know what pi r squared means? Guys, I'll give you a hint. Has a circle.
yeah,
The area of a circle, yes.
right.
A circle. And if I wanted to figure out the perimeter of a circle, all I had to do is just differentiate this with respect to radius, and I get 2 pi r.
Oh,
Yeah, so that's a relationship there you could look at. Typically, when you differentiate, you you decrease the dimension. So area would be volume would be 3 dimensions. If you differentiate it, you get area, which is 2 dimensions. If you do perimeter, is 1 dimension. That's something cool you could keep in mind. So those are some hints. Maybe that might help you get through with your answer. And the other hint is maybe you might have to find two different rates of change. Like maybe you might have to use the chain rule twice.
mm-hmm.
You're feeling like you could solve it now.
I'll try it back now.
Well, I have some, well, I definitely give you some extra bits of information that you didn't see before. You didn't see that before.
No, I didn't really think about that.
Yeah, well, now you know. Now you know. Right? So, Aliyah, let me check what you have here. Aliyah, you are correct. But I would write that as 450 pi. Right?
Okay.
Yeah. Excellent job, Aliyah. Excellent job. I want you to send you working on the chat.
Okay.
So, Nicholas, this is how your working supposed to look. And Aliyah, it have some small mistakes you make there. So the unit, right? If we're talking about dV over dt, that is volume. Volume is what?
Q.
Right. So that's supposed to be centimeter cube per second.
Okay.
So I'm going to do work in here. So water is poured into a cylindrical cylinder. What's in? A cylindrical container of radius 15 centimeters. So they're telling us that the radius is 15 centimeters. Aliyah, if you are filling a cylindrical container, will the radius ever change?
No.
No, how the radius will change? When you fill in a cup with water, the radius has changed?
No.
No, it will change. The height is changed. Height is the only thing that's changing. So R is equal to 15 centimeters. And they're saying the height of the water increases at a rate of 2 centimeters per second. So that'll be dH over dt. Right? And that'll be equal to 2 centimeter
Per second.
per second. So they gave us that as a fact. And they're also giving us the formula for volume. So they're saying volume is equal to pi r squared h. We might have to use that anytime, Aliyah, Amy, Kiara, Kirsten, Nicholas, anytime they give you some formula, just know you would have to differentiate that. Just know that, right? So Aliyah, they didn't give you that formula for style. You had to differentiate that. The thing about this equation is it have two unknowns, right? It have R and H. And
Yeah.
is pi unknown? Aliyah, tell me fast, is pi unknown?
No.
No, it's not. So we would need to figure out what we're going to differentiate with respect to. Are we going to differentiate with respect to R? Are we going to differentiate with respect to H? We can
With
figure that out.
respect to, okay.
We can figure that out.
Mm-hmm.
And they also want us to find the rate of increase of volume. So when we're talking about rate of increase, we typically talking with respect to what? We say in respect to what? Tell Malia. Anytime I'm talking about rate, it's with respect
Time.
to time.
Time.
Time. Right. So we need to figure out dv dt. So to figure out dv dt, that would be dv all over something multiply by something all over dt. And Alia, what's the other variable that just floating around here?
TH.
H, right? DH. Notice I didn't use R. I did not use R because ain't I quite literally have DH dt? Ain't I have DH dt?
Yeah.
So in this DH dt would come over here.
Mm-hmm.
Yeah, so I would not use R, even though I have R. I wouldn't use R because R is a constant and R remaining same. Like if I pour water into a cup, the radius will not change. The height is what will change. The radius will not help me. So awesome. Do we have the HDT? Tamalia, do we have the HDT?
Yeah.
Do we have the VDH? That's the question.
DVD?
Yeah, do
No.
we have the VDH? No, we don't. So we need to find that. And what we're going to use to find this?
The formula that they give you for volume.
Exactly. Because they didn't give you it for style. You need to use it. So
Mm-hmm.
what are we going to differentiate with respect to? That's the other question. Well, it's quite
Um,
literally DVDH. So,
they give
we-
you with respect to height.
right. If we differentiate in with respect to height, is R a variable then?
Yeah.
No,
Wait.
no.
Wait. What you say? A variable.
If we are differentiating with respect to height, so we
Mm-hmm.
if we differentiate in with respect to height, we are only looking at how height changes the volume. We're
Yeah.
not looking at how radius changes the volume.
No.
So that is we're going to treat that like a constant.
Yeah. Yeah. Yeah.
So we're just going to differentiate. So I want you to just imagine that pi r squared is a term by itself by h. Since is by h, and anytime you differentiate 5x to something is get 5, or like 2x is 2.
Mm-hmm.
So if I differentiate pi r squared h, the answer is just pi r squared, right?
Yeah.
And what did it tell us the radius was?
Radius was 15.
Right, r is equal to 15. Right, 15 squared is 225, 225 pi. And we need to keep in mind the units. So Aliyah, it's volume over height. It's volume over height. Volume is measured in
Thank you.
centimeters cube and height is measured in some of us,
Centimeter.
centimeters, right? So if you have centimeter cube divided by centimeter, what would you remain with? What is centimeter cube divided by centimeter?
Centimeter squared.
Yeah, cool. All right, so the units there is centimeter squared. So I'm going to write now 225 pi centimeter squared multiplied by dh dt. dh dt is 2 centimeter per second. Right. So Alia, I want you to run me through the multiplication. What is 225 by 2?
450.
Right? Cool. 450 by pi. And what is centimeter squared by centimeter?
Um,
Cm squared by centimeter.
Centimeter.
It's not hard. With x squared by x.
Oh, x squared.
No, x cubed.
X cubed. 2 plus 1.
Watch, x squared by x is x cubed. So what
Yeah.
is centimeter squared by centimeter?
Centimeter cube.
Right? S minus 1. Does it make sense? Let's look. What is v over t? What is v over t? Tell Malia. Volume is
Centimeter cube.
all over.
Seconds.
Right. Centimeter cube per second.
Per
Awesome.
second.
So we good?
Yeah.
Nice. Right. Right. So I started class late, so I'm gonna give you all one more question. Let's look for one more question. See if we find one more question. Right. I want you all to try this question from here. Question 2. A spherical balloon is being inflated at a rate of 10 centimeter cube per second. How fast is the radius of the balloon increasing when the radius is 5 centimeters? I would like you all to try that. Right, so Nicholas, we aiming for full working. I need to see the full working for you to get the full marks. So Aliyah, I think you get the hang of it by now. I expect you need to get question 2 correct. And here and Kristen, I haven't got any working from you all since you start a class. So I would appreciate if you all try question 2. Right? Amy, how question 7 treating you? You figure out any new pieces of information?
Okay. I kind of figured it out, but like I do a bit of scrapbooking.
Mm-hmm.
So I got an answer, but the unit's not working out. So
Ah,
I want to do it back properly and see if I went anywhere wrong because I just jot down something fast. I end up using two different rates of change.
right.
And so I end up finding for DVDT and um well I already had for DVDT and I had to find for um D wait DH over DT, which was one I use like to find for DA over DT.
You realize I do have the HDT. So I need to
Yeah, but I was finding it in the first rate of change, so I could use that to
I
find for the yeah.
use the DVDT in that. So to find
Um,
for DHDT, that'll
yeah.
be dVdt. Wait.
Well, we can real terrible if you want to see it.
Nah, fix it up and then send it to me.
Okay, okay, yeah. But I have a good idea what I'm doing though.
That's good. It's one like I don't think a question like this would come. This is something that would come in probably the paper three or um lower six.
Rajiv, Aliyah said that her laptop died, but I just want to send you the question so she could still give you an answer.
Okay, cool.
Yeah.
All right, so did anybody do question two? Yeah, did anybody do Question two. Hmm. And I hear any responses. Amy, and you did question two already?
Yeah.
I think that was one of the questions for homework, right?
We did do that
Ah,
in class.
that was five and six.
Yeah. I think I sent in 5 and 6 already do.
Yeah, yeah, yeah. Summer five and six.
Yeah.
Right. Right. So, so I'm gonna do question two on the board. Right. So Amy, I want you to help me with question two. Right. Yeah, so Amy, help me with question two.
Okay. So first the question saying, well, the spherical balloon is being inflated at a rate of 10 centimeters cubed per second. So the first rate of change is dV over dt, which is equals to 10 centimeter cubed per second.
Right.
And then the question saying that how fast is the radius of the balloon increasing when the radius is 5 centimeters? So, well, that's an explicit information. The radius is equal to 5 centimeters.
No, but
And
fill out the question. They said how fast.
mm,
I want you to
or
fill out the question. They're asking you how fast.
how fast is the radius of the balloon increasing
Right.
when the
Wait, that's all. So that's the main question there. That's the main question. So we need to figure out that. So how would I write that in differential form?
dr over dt.
Yes. That's what we need to find. And they told us that R is equal to 5. Right, so let me see how we can figure out. Oh, and they also said the volume. They said the volume was equal to 4 over 3 pi r cubed. And we need to figure out dr dt.
Mhm.
To figure out dr dt, we know dr going to go over here. And we know that dt going to go over here. And the other variable, the only other variable we have is v, right?
Yeah.
So how would I figure out dr dv?
You would differentiate the volume, which is, yeah, dv over dr, and that would be 4 pi r squared.
Mm-hmm. But is that dr dv?
No, so you have to flip it to get dr over dv.
Right. And that will be equal to 1 over 4 pi r squared, right?
Yeah.
Now we need to, they told us the radius was 5, so we need to plug that in. Right, so what would we end up with, you mean?
100 pi.
1 over 100 pi, that's correct. And the units, you have radius over volume. So that is centimeter over centimeter cube.
Mhm.
So what is centimeter over centimeter cube?
I think the minus, like -2.
That's correct. Right, so we have 1 over 100 pi cm minus 2 multiplied by dv dt. We were given that, and that is 10 centimeter cube per second, right? So, Tama, how is it going to work out, Amy?
It
How is,
would be 10 over 100 pi,
which is?
well, 1 over 10 pi centimeters per second.
Right, so 1 over 10, a centimeter minus 2 centimeter cube, same base, multiplication, add 3 minus 2 is 1, right? So that's just centimeter per second. Right.
If we had the pi,
Oh,
the, the
shucks.
pi, yeah,
Right. That's the answer. Hmm. Yeah, guys. So that's it for class today. Um, Next class, we'll do some harder questions on this and we'll move on to something new. I want to move on to more typical questions, like finding the equation of the normal and the equation of the tangent, right? As well as stationary points. Those are things that comes more frequently than this. So, thank you for coming to class today. Amy, I'll see you tomorrow, 10 to 12, right?
yeah,
Yeah, Amy?
yeah, yeah.
Yeah. Cool, cool. Um, Nicholas, thanks for coming to class today, even though you were sick. Kira and Kristen, I didn't hear any of you all, but thanks for coming to class. Hopefully, learned something. But yeah, later, everybody. Take it easy.